So just wanted to understand why is why are we getting this kind of error? Though these files are there, actually, I checked different codes also where I could see these files, but
Mhm.
then it says no such file or directory. So after that, I am unable to run any other code.
Okay. And this is a zip file, right?
Yes.
Compressed file. Okay. Directly you can read the compressed file also.
Okay. I mean, you're saying that we'll be able to do that?
Hmm. Read
Okay.
dot. So let's take this flight underscore data
Uh-huh.
that has a CSV within this.
Correct.
It's a compressed file, right? So you can directly use read.csv
Mm-hmm.
and spark.read.csv to read this GIF file.
Okay, I'll try that. I think, in fact, I had tried another CSV file also where it said the file is not available. So the same kind of error I had got when I tried to read a CSV file.
Is it? Uh,
Yeah, maybe I will try to open that code. But then yeah, so this is one, and the second one I got was here where it said infer schema is not defined.
wait a moment,
Sure,
please.
sorry.
In for schema, you have to say equal to true.
I try. Okay, I tried that also, that option as well.
T
It's
caps.
oh, I, so this is the one I was talking. So this
Okay.
where it says path does not exist.
Wait a minute. Wait.
CSV.
Now
Sure.
go to data. Go to data. In the left hand side panel, there is a data option.
Yeah. Sure.
Tables. Create table.
Yeah.
Then dbfs, file store, tables, no data.
Yeah. Okay.
So first you have to upload the data, right? So click on upload file, click on upload file. Now you can just drag and drop here from your
Okay.
location.
Okay. Okay. So I think I'll need those files first. So probably I'll first get those files and I'll have them uploaded here
Yeah,
then.
yeah, it is completely empty. So this dbfs doesn't contain any files.
Got it. So where are the files available? Was it like shared in the class or?
Yeah, it is in the LMS.
Okay, fine. I'll do that. Yeah, sure. Thank you so much.
Okay. So any file you can just, I mean, right now you can just try from your
Ah,
local machine, just drag any CSV file on this.
okay. I may not have any file accessible immediately. I'll do this. I got it. If
Hmm.
I, yeah, have an issue, I'll come back to you.
Sure.
Thank you so much.
Okay. Bye. Okay. Anyone else has any issues? No questions? Okay, let me ask questions then. Okay. What is a DAG scheduler? Can anyone explain? Am I audible?
Yes, sir.
Yeah. What is DAG?
It helps in scheduling jobs in within Apache Spark.
Scheduling jobs. Okay. And what is the advantage of having a DAG?
Actually, it is like a layer of jobs that will be processing. Like it helps in execution of jobs.
Execution of jobs. Okay. Okay, fine. What is a Spark driver? What is a Spark driver?
Spark Driver is actually a program that helps, that helps in the processing of RDD data,
Mm-hmm.
and yeah, and also it controls the master,
Controls the master.
as in what execution needs to be done.
Mm-hmm. Okay, fine. So what is DAG scheduler? So DAG scheduler basically it computes or it prepares stages for each job. It submits them to the task scheduler, which determines the preferred locations for execution of certain tasks. And also the DAG scheduler finds uh, like the schedules to run those jobs in different stages itself. So it remembers the entire flow, how the job is getting executed, right? And it prepares a flow completely. Now you can download the DAG, you can share it with the clients, you can share it with other team members so that they don't have to run those programs separately. They don't have to maybe write those programs from scratch. That's basically the DAG scheduler. What is Spark driver? Spark driver basically responsible for creating a Spark context. And why Spark context is required? Because you need to schedule the jobs for execution. Okay. So the primary role of a Spark driver is to create a Spark context, which means the Spark context is basically representing a connection to a Spark cluster. Now, once the connection is established, you can create RDDs, you can create operations like transformations, actions that need to be performed on top of those RDDs. Okay. Now, another question, the cache layer, when we do a RDD cache, right? Sometimes we don't want to import the data again and again. In order to save time, we just do rdd.cache. The cache layer getting stored in which node? Is it in the master node? Is it in the worker node? Is it within the executor of the node? Where it is getting stored?
I think Pradeepta, it should be executor.
Good, very good. Because cache should be always to be stored within the executor itself. So that's the fastest way to access the cache layer. Okay. What's the difference between df.take versus df.head? We know there are three functions.
DFT, yeah, df.head is a tabular format where we get the output, but df.take, I think, is the columnar format.
Okay. And what about df.show?
Df.show is used for the Spark data frame, which it's not there for the RDD.
Okay.
And yeah, I mean, it shows in the tabular format only, but it is for the Spark data frame.
Okay. Okay. Fine. Okay. Next question is about I will tell one operation. You have to tell me whether it is an action or it is a transformation. Right? Map and flat map. Is it action? Is it transformation?
They are transformation operations.
Transformations. Okay, very good. Reduce by key.
Action.
Is it transformation?
Correct. It's a transformation. It's not action. Aggregate by key.
That's an action.
No, it's still a transformation. Combine by key.
Transformation.
Right. Left outer join.
Sorry.
Left outer join.
That's an action.
No, I
No,
think it's transformation.
it is
Right.
still transformation.
Both left
Pradip,
and right.
Pradeepta, can you please explain transformation and action once again? Because I was not there in the last class. Probably I'm not able to, I didn't understand. So if you can just explain.
Right. Action is something which returns the output to the driver program. Okay.
Okay. Transformation is like changing some data totally.
Transformation is deriving another RDT based on the primary RDT or parent RDT.
Right,
But
right.
you are
Okay.
not
Yeah.
storing the data. You are not storing that data, right? As an example, let's take combine by key. So you have two data frames. Data frame 1 has 100 customers. Data frame 2 has 150 customers. Just think about you have to do a VLOOKUP like Excel, right? So you have to just identify out of this 150-second data frame, how many of them are coming from data frame 1. So you just have to basically take a union of it. So what you have to do, you have to do combine by key. Key could be your customer ID. You have to combine the two data sets. Now, when you combine the two data sets, you will get another RDD, right? But this RDD is something which you have to store it somewhere. If you are just viewing the results of this combined data frame, it's just a transformation, right? The moment you store it, as an example, you save it as text file, save as object file, save as Hadoop file, save as a Parquet file, or save as an object file, Python object file, right? The moment you write the syntax dot save as some file, now that becomes action. Any kind of save option on any data frame or RDT, that becomes action. However, before that, whatever activities you are doing, like group by, reduce by, like aggregate by, sort by, sampling by key, or join operations, inner join, outer join, etc. Or you simply do a data split, which means in Python, usually you do random split, right? When you do a trend test, 80% training, 20% testing, you do a random split, right? So instead of that, here you can just do a partition by. Now partition by a specific key or partition by a specific operation. If you want to do, then in that case, you have to just do a transformation. Now post partition, you want to save the data frame somewhere. That becomes your action. Clear?
Yeah, got it. Thank you.
Okay. Now there are some additional actions also. Actions could be like maybe histogram. Maybe you are doing a count of approximation count, approximately distinct counts, etc. Right? So these are all again actions because it returns the result to the driver program. So how do we define the actions? By default, the action performs a computation based on the RDD and the operation that you have chosen. It could be mean, max, sum, average, aggregate, variance, standard deviation, etc. Suppose you are writing a function called mean and standard deviation of a column. Now it will definitely throw some result to you. Now that result is basically a single point result, either a mean single point, standard deviation single point, right? So this computation result based on RDD, right? Always it will return to either a driver program or you have to store it to a storage system. Either you can objectify it, store it to another object, or you can store it maybe in the file system, like save as text file, save as object file, or Hadoop file. You can do that also. In both the instances, this is called an action because it returns a result by default to you. Okay, fine. Next question. What's the difference between RDD versus data frame?
Data frame is also a form of RDD, but RDD is not a data frame. But it's kind of similar only. But there are few functions or the actions that can be performed on RDD, and there are many more actions that can be performed on data frame.
Hmm.
Like a data frame is a RDD, but RDD is not a data frame.
Very good. Very good. Okay.
Yeah, RDD is a distributed collection of data spread
Data set,
across
yeah.
many machines in the cluster.
Yeah, RDDs are immutable.
What about data frame?
Data frame is
Data frame is also RDD,
distributed
right?
collection of data. Yeah, it's again distribution collection of data, but organized into columns, like named columns.
No, that is still immutable, right?
Yeah.
So, as I think Jyoti said, right? So, RDDs are like data frames are RDD, but RDDs are not data frames, right? Which means all the RDD properties are being assumed in data frame as well. Yeah. Okay. Fine. So we can go ahead with the new notebook. Gauri, can you please make me the presenter so that I can share my screen? Gauri, you are there? Anyone from program office on this call?
Yes, sir. Sorry.
Yes, sir. I have already made you a presenter.
Okay. So Aruna, this is one example here. You can see this is a zip file. This is a zip file. Directly you can read this.
Got it.
Okay.
Yeah.
So you can just we can try this right now. So I have to attach the cluster. So this is a sample. RDD. This you can read. Okay. Fine.
Okay. Got it. Got it. Sure.
So this link or this file path should be correct, should be accurate enough.
Got it. Yeah, I think in my case, the files were not there. So that was
Yes.
the issue. Got it.
So now you know how to upload those files. So you can directly drag this zip file there and
Got
you
it.
should be able to use it. Okay.
Sure.
So,
Thanks.
yeah. Okay. So in this notebook, what we are covering is that creating RDD, uploading from files or reading from files, and applying those transformations: map function, filter function, flat map, distinct, sample, left outer join, repartition, Action point of view, take, reduce, count, and save as text files. I think all those things we discussed in the previous session. Anything I need to repeat from this list, please let me know. Do I have to repeat anything or is it clear?
I think Pradeepta, we are fine, so you can proceed.
We can proceed. Okay, good. Next, I will go to second notebook. This notebook talks about reading the data from JSON file format, which is a very common file format because most of the applications it generates or stores the data in a JSON format. So in the JSON structure, this is the generic format where there are three kinds of JSON structures. One is like regular JSON structure. There is a nested JSON structure, and the nested and hierarchical. There are two kinds of JSON structures. Hierarchical, it is a little bit difficult to parse, and nested, it is still. See, hierarchical, you have a proper hierarchy which is defined. Nested, there is no hierarchy defined. Both are looks like same thing, but there is a difference in it, right? So the complex data which is getting stored in either Mongo or it is stored in some other NoSQL databases, sometimes it has inherent hierarchy, but the hierarchy is not standardized. That's why it becomes very nested JSON format. Okay, so we should be able to process all three kinds of JSON structures. Now here it is a very basic JSON structure that we are following. Okay, so it's a like having key value, etc. So there are three different records that we have over here. We can simply read this JSON structure and then we can start. So Spark read JSON and it will ingest a Spark job over here and we can see the results. Now here, once the JSON is being read and it's becoming a data frame, then what we can do, we can write queries on top of it, right? So this is one data frame. The JSON is converted into a data frame. Okay, so let's see swimmers. It's there here. We can just do swimmers JSON dot show. Here it tells age, eye color, ID, and name. Those are the four variables that we have over here. Okay, now this one, if I have to write some SQL queries on top of this particular table, I have to create a temporary view of it, which is called reflections. Okay, so any data frame, if I have to query it, not necessarily this data frame would change. So what I have to do is basically I have to create a temporary view of it. Either create a view or replace if it is existing as a temporary view and give a name to this view. So the view name is swimmers JSON. Okay, now check.
Pradeepta,
We
will you
can
be
just write
sharing
SQL
this?
queries. So
Sorry to interrupt. Will you be sharing this the Python code so that we can execute at our end as well?
yes, I can share it. I'm just thinking. I was thinking to cover those concepts first, then I can share these
Right. You
notebooks.
can go ahead. You can go ahead with the
Yeah,
concept. Probably at the end you can share. Yeah.
yeah. Towards the end, I can share because see, I mean, in previous batches also, what I did usually is that if I share these notebooks now, so your focus would be on running the scripts. So And so I would want you to first concentrate on the concepts and understanding those concepts. Then post session, I will share those notebooks, right? Or
Sure,
else what I can do, I can share my login ID password for this community edition Databricks. You can go ahead to the workspace and start downloading these files locally. So you can go to files and export it as a IPython notebook. So this will store this notebook on your local machine.
okay, fine, thank you.
Okay, so this way you can do that. And parallelly, if you want to do practice on something, I can put maybe suppose this one. This is the data that I'm using here. And if you want to do practice, I can copy it and paste it in the chat window so that these are like smaller syntaxes you can write and practice, right? So full notebook I will share after the session. Is
Right, okay.
that okay?
Yeah, Pradeepta.
Okay. Next one is execution of the SQL queries. So standard SQL queries against a reflection which you have created using the Spark pipelines. Spark.sql. Now this is your SQL query. And once you execute it, remember this SQL query is getting executed. It is creating transformations. There is no action. The moment you say collect, now this becomes action. If I remove collect, done. This is just a transformation. There is no action performed in this case. The moment, because you can't see the results here, you can only see this is a data frame, this is the variable, and this is the data type. It's a big integer, it is a string, it is a string, it is a string. That's what you will get. However, if you want to see the data where this condition is being satisfied, right? So you have to use collect function. Now collect is an action because it returns the result to the driver program. Okay, that is one way. The second way of triggering SQL query is this. You can just use a percentage SQL symbol that tells the Spark engine that you want to write a SQL code on top of a reflection. This is one way, spark.sql. This is another way, right? In this way, you can simply write the SQL query without a quote even and not even needed the collect function. That's it.
So in this case, Pradeepta, the second one, will it be a transformation or will it be an action? Because it's showing the table as well.
It is action.
It's an action, okay.
It's an action because it returns the result to us.
Yeah.
Okay. So these are two alternative ways. Now, when to use what? If you're in the exploratory stage, you can use this. If you want to consume this result going ahead, right? What you have to do is simply you can just assign it to result equal to this. And you want to use this result subsequently in your remaining script. You can still refer to this object and start writing things. However, if you want to assign it result equal to this, right, this will throw error. Okay, this is just for viewing. It is not for using as an object-oriented language programming. This way of writing query, this is just of exploring the data, looking at the data, and maybe see this result you cannot store. If you have to store the result and subsequently use the stored result, then you have to write this way. Spark.sql, objectify it, assign it to another object, and start referring this object if you want to use this result somewhere. That's the only difference. Now, so this one is faster in comparison to this, because this is processing it in two stages. First, it performs a transformation, then it performs an action. This one directly performs an action, which means here no reference is required. That is why this view is faster. If you want to do quick execution of certain scripts just to explore a data table within Spark, This is for exploration purpose. This is for programming purpose. You want to use this result. Suppose you want to do, you have written a query and you want to get that result. Now this result data set you want to use to train a machine learning model, right? So this way you have to write the script. Clear? These are the two ways of writing SQL queries. Now, inferring the schema using the reflections. Okay, so either we can do infer schema equal to true while ingesting a file, right? Or if you are not making infer schema, then by default, a default schema would be assigned to it. So Spark will automatically determine the schema based on the data itself. Now here age, earlier it was recognized as big integer, now it is long. Okay, so let's see. Yeah, this is long, this is string, this is string, this is also string. So Spark was able to determine the infer schema automatically when we do a print schema on a reflection. Next, what happens? If you are ingesting some data, you can also define the schema here. The schema definition you can provide by using a syntax called structure type, struct type or structure type. And within the structure type, you have to define each and every field, what type of data you want it to be. Okay, so let's take schema string. There are 4 columns: ID, name, age, and eye color. This is your sample data. Suppose this is ID, this is name, this is age, and this is eye color of 3 different persons' data. Now, what I'll do first, I'll define the column names, which is I can call it like schema string. Then the schema definition, structure type. Now, for a specific column, I have to use a syntax called struct field. Struct field, it should be either long, it can be string, it can be boolean, it can be anything. So I have to specify what data type it is and whether it is true or false. This data type, make it true, right? So like this, I define the schema. Once the schema is defined, then you can use read the JSON or RDD or data frame and apply a predefined schema on top of it. Now, once you apply the predefined schema, automatically the schema will be covered here. Now you print schema. Now, if you make it false, what happens? Right? Now, what happens? It did not change. Why? Because this is RDD. It cannot be changed. The moment you change this, you have to write a new name to it. Swimmers 1. Okay. Make it swimmers 1 and print swimmers 1. Right? Here it is false because you have given it false. Clear?
So it says nullable equals to false. That means there can be a null value, right? There cannot be a null value.
Right. Right.
Okay. One more thing over here, Pradeepta. So can you just go a little up? Yeah, over here, over here. So you have defined a variable called as schema string. Are we using this somewhere?
This is schema string. No, we are not using it.
It's just a string.
It's just a string.
Okay.
Because no, we are not using the schema string anywhere.
Yeah, I just wondering why have we defined that?
No, that's not. I think for a different purpose I defined it. It's not required. Only thing I think you have to refer it here. So this is manually, I just fed the names over here. Now, if you have to automate this, suppose this is like having 4 columns, that's why you are writing ID, name, age, eye color, etc. Okay. However, if I have my 100 columns over here, so what I'll do, I will write a schema string over here. This part I will say schema string index 1, which means schema string index 0, right? Index 1. So in this ID, here I can specify 0 till 2. Now this becomes my ID, right? So here, and I can just do plus addition over here, plus 2. Sorry. This is one field and it is a one single space specified. So plus 1, I can just do add over here and then skip another couple of things. So yeah, if I have to dynamically use the column headers over here in this struct field and programmatically keep on changing it, then I have to use this schema string. I have to define the column string somewhere. That's why it is there. But right
Yeah,
now, only 4 columns, it is fine.
right. Okay. Got it. I
Okay.
think array would be fine, instead of string, they can have the index, read the
Array is
index.
also fine. Yes, yes.
Yeah.
Array is also fine. Or a simple list is also fine.
Yep.
Okay. Next, pairing with SQL. So this is again, this is one way. Now here, this is again a transformation. This is not an action because we do a show here. We are not doing collect. So the difference between show and collect is that show would be a temporary view. Collect would be an action that returns a result. Okay. Now just we want to see the outcome of the data, we can do a show.
So collect, when we are using collect, right? Are we storing in some variable?
Collect we can store, but currently we are not doing that. If we want to store it in a variable, we have to assign it to something.
So now the collect here becomes a transformation, right?
There is no collect here.
No, I'm saying like when if we are not assigning any variable,
Hmm.
collect will be a show.
Yeah, it's transformation. Okay. Now this one, like we are just changing the SQL queries and different kinds of SQL queries. Select count 1 from swimmers, etc. This way also you can select. This is another way. Okay. And you can perform filters. So this is your the reflection view. Select different columns, put a filter, and this is one way of writing a filter query. Okay. Another way of writing filter query is here. Swimmers, select, and give reference to the ID. Now this way of reference is better. Why? Because sometimes you may commit mistakes over here. Now suppose age is given A capital and you are writing, actually suppose let's take it is small lowercase and you are writing age as A capital. So this will fail. This will not work, right? Fine. But how it worked here? Here also it changed because your filter is already working here. Now if I make it age capital here, still it works. It should not work, right? Because your column header is lowercase. Any thoughts?
But I mean, in SQL, when we do the SQL query, Pradeepta, I mean, I'm not sure whether headers are case sensitive.
Should be, no? See, by default, it is all lowercase. Even if you provide a capital in the query, it should not work.
This side, whatever the ID and age, right? They are the names that we are given. That should
Hmm.
not be a problem. But in the filter, I have a doubt actually how it is working.
Right.
For a schema, it is small age, right? Like,
Mm-hmm. Now, if I change the ID also, let's take. Still it works. It will fail.
Yeah, I think it is not case sensitive.
It is not case sensitive. So the temporary view that we are creating for a SQL table, the reflection that we are creating, the column headers are not case sensitive. Okay. And it's fine. But we usually don't remember those things. Right. Now, suppose instead of age, it is ages. Somebody types, it fails. Right. Now, uh, this is simple. This is very simple. ID, name, age, etc. Now think about column headers like this. Customers returned in last 3 months. This is a column header. Who will remember this? In this format, it is written as a column header, right? Column headers can be KPI in uh, last financial year. This could be the column headers. Nobody would be able to remember all those things, right? So in practice, it is very difficult to collect those names so that we can use it in the SQL queries, or we can apply filters on top of the data. That is why the best way is you refer this by putting a dot operator and simply do a tab, right? As it is, it will come up over here. So here we can find the data. Just do I. Why the drop down is not coming up? Swimmers. Ideally, it should come up in the tab option. Not a problem. So what you can do is you can always use the tab operation here to identify in the drop down what column it is, so that it is easier to make a selection from the existing name of the columns. Now this way is a better way of writing if the column headers are having many characters, too difficult to remember. Sometimes it is underscore, sometimes it could be hyphen, but SQL tables cannot have a hyphen. It should be always underscore, always. But still, we can expect redundancies like this as well. Sometimes we can expect redundancies this as well. So these kind of patterns, we have to clean it up. And basically, when we get such kind of patterns, it's difficult. We cannot remember all those things. And especially in many columns, when you have more than 30, 35 columns, it is very difficult to remember all those things. That is why we have to refer the data frame way of referring to the column headers so that we can use it in the filters. The only difference here is here it is a single equal to, here it is a double equal to. That's the only difference. Here automatically you can use the object name and dot, and then you can take a column header here. and you can apply filter over here, and you can just use a double equal to here as a equal to operator. So this is the only difference. And performance wise, you can say which one is better. I think equally, both are equally good. Okay. This is just another way of selecting. See, there are three ways. This is one way using select. This is another way using select. The same query here in another way, where you can just use spark.sql, select id as. Now this is SQL lovers, they will follow this. This is more convenient for them, right? And this is the fourth way. This is specific to Databricks notebook format. So how many types now we covered? 4 types, right? First one, first select the columns that you want, or the column or the attributes that you want. Second, apply a filter, put the filter condition and do a show. This is first way. Second way, using data frame references, take the reflections data frame dot column header as a reference, apply filter, put a double equal to as a filter criteria, it works. Third way, using a SQL way of writing script, and this SQL code as it is within the spark.sql pipeline. Fourth way is specific to Databricks notebook edition, or here Databricks notebook way of writing. Now this is also like you'll not be able to store this result somewhere, but you should be able to see the results right away from this cell itself. You should be able to see. Clear?
Yep.
Okay. Next one is the wild wildcard search. Select name, eye color from swimmers, where eye color is like brown or blue, etc. That's one way. This is second way, right? And this is fine. This is just a show. This is a display, which is nothing but the tabular view, and get the count. This is an action because you want a single output as a result. Count. This is already we have discussed. This one also we have already discussed. Okay, fine. So next thing is, instead of a sample data, let's go ahead with a little bigger data set where we have the departure delays and airport codes. So this is some data set which is taken from flights database. So flights database is nothing but, if you are used to R programming language, there is a library called Newark flights. This Newark flights is a database or data set which has almost like 6 lakh records or something. I don't remember how many records are there total, but I think 6 lakh records or something. So I have downloaded those two files separately, departure delays.csv and airport codes as txt. So airport codes, all the international airport codes will be there, and the flight's departure delays would be there. Now basically we need to read both the files, combine it, and perform queries on top of it. Okay. Now these two files I uploaded to data, collected their paths and used the path here. This is set file path. Next, read.csv, airport file path, header equal to true, infer schema equal to true, separator equal to tab. It's a tab separated data file, the CSV one. Then we'll just create airports as a reflection here. Create temporary view, call it airports. Then get the departure delays and then store it as flight performance. And cache the departure delays dataset. Flight performance because this is big data set. And if you want to do a cache here, it is easier for us to write the queries in a faster way. So let's execute it. Okay. I think last session also I discussed about difference between cache and persist. Cache versus persist. What is the difference? Anyone remembers?
Cache will actually store the data. Persist will commit the data.
Sorry.
Cache will just store the transaction or the data temporary, sir. While persist will permanently commit it.
No, not exactly.
So probably if we want the faster execution on some data, and we should cache it because it is stored at the executor node.
Okay, let's do it this way. Three things: default memory, disk memory, mix memory. Go to the storage. Okay. Our storage is completely empty, right? Yeah. There are jobs which are running on this driver. There are, you can see so many tasks over here. And we are not storing anything in the memory. There is no data that is we are storing in the memory. And these files that we are reading, we are just reading it from the data tables, which are nothing but the Hadoop tables. Once we import the data to this data DBFS folder, it becomes Hadoop files. So the CSVs are being stored, right? Now here in memory, we are storing nothing. Now if you just go to executors, there is a default storage allocation over here. Okay, what is that default storage? Let's see this. This is executors. Maybe this one will have. No, it's not having it. Go to SQL. These are query computation times. This is also not storage. So we are not storing anything over here. We are not storing anything over here. And the default storage is there. I don't know why the default storage is not being shown over here. So there is a dedicated memory which is assigned to this. Okay, let me check this one. Environment details. This is frame size. This is okay. This is AWS. 120 minutes. Just trying to see the default storage here. How much is there? This is Scala version. Driver maximum size is 4 GB. This is the default driver size is 4 GB. Okay. Port temporary directory. So let's assume 4 GB is our max size that we have over here. Memory. Okay. So this whatever we will be storing, it will be storing in the memory itself. So let's assume 8278 MB. How much it is going to be? This is chunk size. This is block size. 10 attempts, maximum to 32. Interval, this is fine. Make some timeout. Listen multiplier. 8278. This is the executor memory set. This is Hadoop properties. Hadoop properties we should not be looking at. That is fine. Okay, fine. So let's take this is like a 8278 MB total memory allocation. No, Hadoop storage should we look at? No. This is fine. Okay, so let's go back to this. The default memory is, let's take 800 MB. Let's assume that, right? Disk memory, let's take this is unlimited. Mixed memory is which is default plus disk memory, which is by default it is unlimited. Disk memory means it should be defined by the user. So this we can call it user defined storage layer. Default is specific to Spark memory allocation, which is subject to your executor memory. Okay, when you do cache, please remember this. This is important, and small data set doesn't make sense, and you will not be able to find any differences. When you are playing with the huge data sets, it makes sense, right? So if your default memory is more, or default memory, let's take 800 MB, and you are playing with it 700 MB of data. So data size 700 MB, which is less than default memory, which is 800 MB, then you go for cache, which means this is memory only. Okay, it is memory only storage. Now if your data size exceeds default memory, right? Because you would be knowing how much data you are playing with, you definitely would be knowing that. So if your data size exceeds default memory, then you have to, and when you do especially cache here, it will fail because data loss will happen. It can only hold up to the default memory. The remaining data, it will be a data loss, right? Data size exceeds default memory. If selecting cache, data loss will happen. If data size exceeds default memory, then go for persist, which means persist will have two options. You can define, okay, dbfs 123.4.5 and file path is, let's take store. You can define your own DB where you want to store the data. Okay. Now, this is purely persist where you are using disk memory. Fourth option is data size queues, which you do not know. Default memory cannot hold it. So you need, right, greater than even default plus disk storage. Then you go for mixed memory, which is a combination of primary, standby, secondary. Like this, you can set different storage units. You can store on HDFS in AWS. You can store remaining data in HDFS in second bucket in AWS. Like this, you can define primary, secondary, tertiary, 3-4 buckets you can specify, and you can store it. Right? So persist is going to be applied when your data size is exceeding the memory. Okay. Now, this is a combined memory. It is not a single machine memory. Please remember. Combined machine means, so it's a cluster. Now, this cluster, if you just look at, it's a 15.25 GB, 2 cores. This is the cluster. Okay. Now you can, so this is a 2-node cluster. You can set up multi-node cluster. You can set up 10 node, 100 node, 1000 node cluster also you can set, depending on the task. If you have a 1000 node cluster, your default memory size would be very, very high. In those cases, you don't have to do a disk memory. You can go ahead with the default memory. So it's a play of how much data you are playing with. What is the memory allocation for it? Because if you are playing with huge amounts of data and default memory is not enough and you do a cache, it will show keep memory not enough error. Keep memory not enough error you will get. Clear?
What is the difference from the execution perspective? As in, I think you told that in last class the cache is faster as compared to the persist.
Yes, because persist is taking the data out of this cluster to somewhere else like a disk memory, which is user defined storage layer. The user defined storage layer not necessarily on the same Spark cluster. It can be outside of the Spark cluster. That's why it is slow, because next time you want to access the RDT to do some calculations, it will first read the data from external storage system, right? And cache is faster because it is fitted within the default memory itself. So the data that you are trying to cache, if it is fitting to the default memory, you should always cache because that's going to be faster. If it is exceeding the default memory allocation for your Spark cluster, then only you have to prevent the data loss, right? So that's why you cannot just do cache there. You have to store it in a user-defined storage. Either it is in local DBFS or a cloud DBFS. You have to somewhere define it.
Right. Okay.
So we need to get a size of our data, right? Before choosing this.
Yes, yes. At least see this we did a default cluster creation here, right? So I mean here we don't have an option to select. It's a default machine. When you start cluster, it creates a default cluster and gives it back to you. Okay. However, in real life, what happens is that all these environment that you see here, this need to be set. Okay. These are all config properties. The Spark properties that you see, these are configs. These properties would change. Now here you can see the number of clusters. Okay. Cluster source, scaling type, fixed size, cluster size, VM container, cluster spot bit price percentage, 100% cluster state. The number of clusters, it is not giving an option to us. Okay. But uh, on a cloud machine, you will have the option to set up like is it 10 node cluster, 20 node cluster, 100 node cluster. You can define that number of clusters. So based on the cluster, your storage would be updated accordingly. So you will be able to see what is the storage size available. I don't know why it was not showing here. Earlier it was showing. So it will be showing, let's take 20 MB is allocated and this much is only occupied. So it used to give a details around this in the storage layer. Maybe on a local machine, you should be able to see it. This UI has changed. Right now, it is only showing the packet input output cache, but it is not showing the RDD or data frame based cache options are not being displayed over here. Something changed here, I think from UI point of view, because it's currently using Spark 3.2.1. So earlier it used to show the memory allocation. What is for driver memory, what is for executor memory, or how many clusters are there. All those information used to be shown here. Right now it is not showing. So here it is master equal to local. So basically 8 cores by default, 8 worker nodes are there. Local 8 means 8 worker nodes working with master node. Now this 8, I think it comes from, so 2 cores, right? Yeah. So 8 worker nodes are there. So these are all default setups. However, when you practically set it up, anyone has the 7-day data bricks license. While setting up the cluster, you can see the drop downs. How many clusters you want? What is the node size you want to set up for a cluster? Right? What kind of machines you want to choose? Is it 3 vCPU, 4 vCPU, 8 vCPU? What is the size of a machine you want to use? So all those options you can get even for your Azure ML also. When you are setting up a Spark cluster, those configuration screens you will be able to see. There you should be able to change it. Once you do that and go back to again the storage layer, you should be able to see how much memory is allocated and what is left. This is a very like limited edition. All full functionality will not be able to see here. Maybe they have removed the storage and kept it only for Parquet files here. I don't know. This is for cloud edition, but anyone has a local edition. Can you please share your screen? I want to see the storage part. Some of you have already installed locally, right? Kiran, you are there?
Sir, actually, that local one, right? It got expired. So I
Local?
have the community edition. I have the community edition.
No, no. What do you mean by local got expired?
You mean to say that Databricks, right? Databricks
No,
account.
no, no. That is not local. Na. See, local installation is like Spark on your local machine.
So that we never tried. That we never
No, some people that tried. I think, and everybody agreed that you are able to install Spark on your local machine, right? On the group chat.
Yeah, on the first class, I was able to do that. But once my Spark Community Edition got created, right, I stopped using it. So I'm not sure whether it is still usable or
Anyone else? Anyone else has installed Spark locally?
then later I uninstalled it, sir. After the Community Edition started working.
That's okay. Okay, fine. Uh, okay, fine. I was just thinking, like, if anyone has, then it would be easier for us to see.
Sir, I had installed, but when I execute certain commands, right, it's failing just because of that
4J this thing.
But we fixed it last time, right?
No, sir. Actually, even I after multiple after trying to multiple installation again, I'm getting the same error.
So did you follow the Kiran has taken one set of screenshots how to fix it, right?
That was on the community edition, sir. That is completely what Kiran has said is completely on
Oh,
community.
it's community edition. Okay. Mm-hmm. Okay, fine. So okay, so we'll see it in future. Maybe locally, I have not set it up on my machine. Otherwise, I would have shown you. I have not set it, so we'll do that in some future sessions. Maybe next session I can show it to you. I have to because my machine has not been restarted for quite some time.
So,
Hmm.
sorry to interrupt.
Go
So
ahead.
I think I have installed on my local machine, and I check if you want.
Yeah, please go ahead. Please share your screen.
Yeah. The OS is not.
OS is not installed.
Yeah, let me just install that.
Just do import OS on the top. Import OS. System not defined.
Sir,
Same
I just
file.
reinstalled. And it is showing up.
Is it working for you?
It's working now. Yeah.
Okay, you can.
I just reinstalled it. It's working. I'll share my screen, sir.
Yes.
Yes. Please go ahead.
Because I had the codes already available, so I just reran those codes. Luckily, everything just got executed.
Perfect.
This is what it is. I'm able to run till this point.
Done. Okay. Next. Just a minute.
Next, which command should I run, sir?
Spark is already running. Okay, just print Spark.
Print.
No, just don't write print, remove print, just Spark, execute. Click on UI.
Kiran, can you zoom a bit?
Cancel, right click and
Yeah.
right click and open new link. Stage storage. Okay. Nothing, right? Okay. Try to read one file here. Not here. Here.
Import a file, sir.
Read spark.read.csv and provide a path. Any CSV from your machine, you can just pick up. Iris. Okay. Or that VS, that is a bigger one, top one.
This is 128, 126 MB, sir.
This one, that should be fine. Yeah.
Should I give any header equals to or any such things?
No, go ahead with this as it is, and assign it to data frame df.
Just ran
it. Just assign it to df equal to this. Okay.
Done.
Now go to storage. Refresh. No, it's there already on the top. You can just right click. Why the storage is not coming up? See, you have done a CSV. Okay, you do this df.cache. df.cache.
Bracket, sir.
Correct. Okay,
Go
now
back.
Refresh.
No, sir. Still.
Interesting. What is happening?
Else, I have this browser that has logs everything. Just do everything.
The storage should be working here.
Let me just verify. No, sir.
No.
Hold on.
Okay, go to jobs.
Okay.
Uh, Class job is not there.
Completed jobs.
No, job ID 1, CSP at unknown 0. There.
There's
Click on that. Then go to DAG visualization. Yeah, it should be showing.
it shows yours.
No, that is fine. DAG it is showing. It should be showing. See, 126 MB you have uploaded, right? So it should be showing how much memory left and how much memory is allocated. That is not being displayed. They did some changes to this, I guess. Earlier it used to show. Go to executors. 1 second. Active 8 cores, 2 cores, 2 completed. Yeah, this is what I was trying to say. Yeah, 103 out of 413 MB. So storage memory is 413.9 MB. Right now, whatever you uploaded here, it is occupying 1034 KB on the driver, right? This is the default memory allocated to. So when you do cache, the default memory is 413 MB, out of which now occupied is 103. Clear? This thing was not coming up in the cloud edition. This is what I was looking for. The storage memory it should be showing.
Even here we have some same statistics.
So that's the same thing. That's the same thing actually being displayed there. Okay. No, this is nothing. You can just ignore it. That's fine. That's fine. Here you can see the GC, garbage collection time, also being mentioned over here. So by default, garbage collection also happens. Total tasks 2 and completed task 2. 8 core machine. By default, it is 8 cores, 8 worker nodes. And yeah, this is what I was expecting to show in the Databricks edition.
So did we check that executors there?
There as well, if we want to see the executor, no, it is not showing anything, I think. Ideally, it should show there as well.
So, sir, if I'm clicking on this, it is showing something else now. Heap memory also. On heap memory.
Yeah. From this you can select executor memory, resources available. You should be able to see all.
Java. Okay, it is showing everything, sir. Whatever we discussed.
Yeah. By default, if you want to select all, you can see everything here. Okay. So that's why we have to first check both the things and thank you. Thanks, Kiran. I will just share my screen now.
Sure, sir. I'll unshare my screen. Thank you.
Okay. So now we are clear about this is an important concept because you should be aware about how much memory is there and whether you should do a cache or you should do a persist. Those two things. Okay. And apart from that, this is just writing some. These are all SQL queries we just have to write, and little bit of complexity is there because you are adding few more conditions over here. A join condition, a where condition, then doing a group by, then you are performing order by in descending order. So many operations you are performing over here, right? And the data is quite small here. This is not a very big data set, right? Even if it is not a very big data set here, but still, if you run this kind of queries in a local environment using pandas data frame, it will take bit time. Now here, it takes how much time? Let's see. 3 seconds, right? 3.02 seconds. Next time, 2.77 seconds, 2.10 seconds. So how do we know what is the right time, estimated time for the same query? 1.93 seconds.
Cache is something.
No, cache is not there. So I did not cache this data set. The swimmers JSON I have done cache, but this one I did not do. This is the flight performance data. This is 1.57 seconds. I think this is the best, right? Now, why there is a variation in processing time?
Okay, so before that, Pradeepta, I have a question. I mean, if you didn't cache it, so where by default where this particular data gets stored?
This is in memory.
And in default memory only, right?
Default memory only.
Right. So even if we don't cache it, it gets stored in default memory.
Right. See, when you were doing spark.read.csv, you are importing any data set. And see, when do we do cache? That is also important. So when you first, sorry, this flight performance.
I think it's cached.
It is cached. It is cached. Sorry. This is cached here. So when do we need to do cache and when we don't have to do cache? Okay, that's first we need to understand. So this one spark.read.csv, I read this file and for schema true, header equal to true, separator equal to this. This is becoming my data frame. Fine. I can run queries on top of it. Now where this is stored? This is stored by default in the memory only, default memory only. Okay. This will stay in the memory till the time I am on this notebook. If I switch to another notebook, right, this data frame is something which I will lose. I'll not be able to get it back, right? So what I have to do, I have to again read this. When you do read, it reads from the file system, right? This file system is currently with this machine data. That's the file system from where it is trying to read, which is again still not a problem. But if you are reading it from a different location, the data is flowing in through a or over a network. So there would be slow throughput also. And there would be, I mean, depending on the network strength also, the speed will be depending on that. So the bandwidth speed, data coming over network, low throughput, there are so many factors it may impact by reading a file from a different location to Spark environment, right? Especially for big data, like 100 GB or 200 GB of data. It takes time because it may take like, let's take half an hour it takes to read the file itself. Okay, so every time you do analysis, you have to first read this, spend half an hour, and then you can perform your analysis, which is a tedious process. In order to avoid that, what I can do a cache. If I do a cache, it is there in the cache memory of this person who is the account owner. Next time I log in, it's already there in the cache in this cluster. The moment I attach this cluster, this dataset available in the cache is up and working for me. I can simply read this from cache memory and start using it. I don't have to wait for half an hour to read the file again. Clear?
Isn't the cache getting cleared when we probably, log off from this particular session?
You are caching it in default memory, right?
So it will stay there, is it?
It will stay there. If you do a cache clearance, it will go. So you can do a uncache.
Okay.
right? So if you don't want this data set, you do on cache. If you want to use it, like suppose morning time you log in and you are using a machine, now you don't want to do analysis. So this is community edition, it will expire in 2 hours. After 2 hours, the cluster will shut down, right? If the cluster shuts down, this cache will go away. This will not be there because it is getting stored based on the cluster. Next time you again log in after 2 hours, again you have to recreate a cluster. So when you are doing a recreation of a cluster, the cluster creation happens based on the host name, right? When you are doing next time cluster creation, this part is basically may change. It is now currently US West Coast. It could change to East Coast as well. So depending on the server availability, the nearest server it picks up. So your cluster ID would be different. In that case, your cache would be empty and you have to run this once again because this is a community edition. If you have a proper account, let's take a AWS account or a Databricks account, which is a paid enterprise account. Many people they are doing cache now because they don't want to read the files again and again. Some files take 2 hours, 3 hours, 3 days. Every day they can't do a file import. So they have to store it and cache it in the memory. And it will stay in the memory till the time you are doing uncache.
Right. Okay.
Okay, fine. So I was explaining the concept here. Uh, Query timing, right? This is what I was trying to explain. Now, why there is a variation in the query processing time? Variation in query processing time. Why it is so? Because of three things: partition, replication, and file location. What does this mean? Partition is that suppose you are calling the flight performance dataset from cache memory. So if you're reading from cache memory and there are two partitions, right? And two replications. Two replications means each element would be replicated twice in the data blocks, right? Within a node itself. If you have more replication, let's take 6 or 8 replications. Okay, if you have more replications, the query processing time would be again maybe faster. And if your replication is more, you have to increase the partitions also. So increase the partitions, increase the replications. File location can be your local DB. Here it is a local DB for this cloud edition, right? And if file location is somewhere else over the network, the data is getting transferred, there will be a slowness. So virtually I can remove this part. I will not consider it. Only keep partition and replication as two factors which impacts the query processing time, right? So the more the number, the better would be the, or faster would be the processing, because quickly it can access the elements.
But when we are re-executing the query again and again, the previous one, but in that case, we are not changing the partition and replication, right? I
No,
mean,
we
that
are
is
not
fixed as.
changing. Yeah, by default, it tries to figure out from which block it is accessing the data. So there is a lot of randomization here. Because of that randomization, it is like sometimes it is a possible that all the information are present in one block. That's why it is faster. Second time when you run it, again it performs the search. Right? This may take some time.
The local installation, it will be same.
Correct. It will be same. Now, next time when you run again, so see the replication is just like you think this way. This is my data node. This is my second data node. And this is my third data node. And let's assume this part is, this is one. Same thing is stored here as well. Same thing is stored here, here, here. Same thing is stored here, here. Right? This is one information. There can be multiple such informations as well. Now, so how many replications here we can say, right? So replications, okay, fine. I did a mistake here. So two replications, green box 2 would be there. And let's take, this is another block. So which will be, sorry. Okay. And let's select another color. Okay. So two replications means each element is replicated twice and there are three partitions. Across three partitions, it is spread. Now, first time when you execute, it goes searches here. It did not find, then searches here. It finds, and it takes another element from here. Now, in the randomization process, if you run it once more and it is not getting searched in those two partitions, it is finding all three elements in this partition only, then the search would be faster because all two replications are present over here, right? Two blue boxes, two orange boxes, two green boxes. So all those partitions are over here. All the data elements are here in one partition. So this time, if it randomly hits this and gets all elements required, so this would be fastest, less time it takes. If it first searches for these two elements and finds it and takes it up, then it has to first again go here to search for other elements. In the process, it finds these two elements and it has to discard these two, pick up these two, then finds another. The second one is missing. Then it goes here and finds the second one and combines this, reduces and shows the result to us. This is the longest possible query time because first it picks up two elements from this block, then it did not find any other required elements, then it searches for this. But this search is actually not happening sequentially, it is happening in parallel. But while reducing it, right, it tells that okay, there are two green boxes. Here it tells there are two green, two yellow, or two orange and one blue. Here it tells two green, two blue, two orange, or three green, right? Reduce step itself, it identifies what is required and what is we have in the partitions. So parallelly, though the search is happening, the reduce step itself, it is taking time because reduced by key, right? So it is the same element, right? Either this part is copied over here or this part is copied over here. But actually there are like this element, the green elements are one, the orange elements are another, and the blue elements are, so three elements, two times replicated across three partitions, right? So the reduce operation, when it happens parallelly, the search happens on three, shuffle happens on three, reduce operation, it happens, it takes time because it reconciles whether it is present in one block or multiple blocks. However, if it searches here and finds all those things, and these two results would be discarded. So it depends on first where it is hitting first, though it is doing a parallel search. Clear?
Yep.
I have a question.
And yeah,
Yes.
sure, Shrikant, please go ahead.
You only catch the flight performance, right? Not the airport data. Is there any reason for that?
I have done caching for the data frame. Yes. This is the data frame.
Only for the flight performance, not for the airport.
Your voice is echoing.
Actually, I'm in the class, sir. So nobody's.
Okay. So your question is if we are doing for performance, we are doing caching. Yes, that's true.
And why not for airports?
Why not for
Airports.
I'm not getting the term? What is that you are saying?
Airports.
Airports.
Line number
Yeah,
7.
for airport
Okay,
data set.
so
Ah,
let me
Airport
repeat the
data set.
question, Pradeep.
Okay. So basically, you are
Yeah.
saying why you are not doing for airports, why we are doing for performance. Okay. That also you can do because that query we have not running here. We are only accessing the flight operations. Airports we are here we are accessing airports. Yeah. This one I think this is not on flight performance. This is flight performance and this is airports. We are doing a mix here. Yeah, that also we can do.
So here we are not checking for persistence or cache, right? We are directly doing for a cache.
Because we know that this data size is pretty less. It can be easily fitted to the memory.
Okay.
That's why we are not doing persist.
Okay.
See, persist and cache both will work similar way in this case. If I just do persist also, it should work. Right? Because here persist requires a user defined storage layer. We are not defining any user defined storage layer. So by default, it picks up the default storage layer. So cache and persist does not make any difference over here because the default memory is enough to hold this reflection. Okay.
I have a question, Pradeepta.
Sure.
Someone told that, this partition, I mean, the query timing will remain same on the local machine, but it differs over here in Databricks. What is the reason for that?
Local machine query time will be similar.
Yeah, if we execute multiple times, I think someone told that.
No, local machine also it will change. The query time will change. Because it's a function of like how many worker machines you have. Suppose here it is master equal to local 8 core 8 worker nodes are there with a master node. Now if you have 4 worker nodes over here, right, so the query performance would be impacted, right? So local mode also this timing would change, and the timing would change as in like not a huge difference. You can see like little bit time difference,
Yeah,
2.29 seconds, 1 point or 2.02 seconds. Minor changes you can see.
right.
Okay, this is just a view creation, just seeing the data. This is also again SQL query, some additional SQL queries. Yeah, that's all. Now, so we want to take a break here.
Yeah, Pradeepta, short one.
Okay, fine. So we'll be back by 12. Let's take a 12-minute break.
Sure,
Okay.
thanks.
Sure, sir. Thank you.
Okay. Hello, everyone. I hope everyone is back now.
Yeah, yeah.
Okay.
Yeah, Pradeep.
Okay. It's fine. This one is completed. This is simple. So what we have is duplicate, how to identify duplicates, how to identify missing observations, how to identify outliers. These three things we discussed almost in the previous sessions, right? If I remember correctly, we have already covered this one, right? Outliers. You can simply create approximate quantiles. First quantile, second quantile, 1.5 multiplied by IQ or interquartile range. And then you can print the bounds, min and max, upper bound and lower bound. And then you can run against the columns to figure out if there is any outlier present or not. This is something which we discussed before, right? Joins also we have covered to some extent. Okay. Then after that, it is little bit of a descriptive statistics, which this one is reading a zip file and applying lambda function on it. Okay. This is defining the schema and then creating one data frame, Spark data frame, printing the schema, customer ID, genders, state, cardholder, balance, number of transactions, number of international transactions, credit line, fraud risk. Now you perform some group by operations in this, right? So this is a proper data set, the fraud DF.
Is it part of that example or is it ready to upload it?
It's already there. I think I have already uploaded this one. Please check it. If it is not there, let me know.
Sure.
It should be there. If it's not there, let me know. I'll send it right away. Is there?
You mean in the reading materials?
LMS you can check.
Oh, okay. I'll check that. Are you waiting on confirmation? I don't see it, but we can. Day three.
Are we are we waiting on any files?
I think Pradeepta is on mute. So yeah.
Hello, am I audible now?
Yeah, Pradeepta. So we don't have that file in the in-class material.
Okay. Just a moment, I'll share it right away.
Karthik or I mean, if someone can, upload it, Karthik or Gauri.
Yeah, which file you talk about, Jyoti?
Right, the sir will be sharing one file now, data file, so you can upload that.
Okay, now only. Acha, acha, we will upload.
Yeah.
Okay.
Can I share it? I don't have the option to share it here. Okay. Uh, how do I share it? Gauri, can you please ping your email address?
Yes, sir. We will share it. Yes, sir. Yes.
Or else I'm just sharing it in the email, day 3 email. Everyone is there in that email? I hope everyone is there. The dataset is actually 77 MB. It will send a Google Drive link. No, that's not possible. Okay, I'm just sharing the link now. Can you please click on this link? It will straight away download the data.
I'm getting an error message says that it cannot be downloaded securely. Okay.
Is it?
Yeah, but I think it it says it cannot be downloaded securely, but still it is downloading. That's fine.
Yeah, it will. You can directly download to your local machine and then upload it from there. Either Jupyter Notebook or you can download it or upload it to your community database.
Sir, I think you can proceed, sir. We can take it offline.
Perfect. Okay. So 77 MB file. Just do upload here. What we are trying to do, once you read this file, then we are simply removing the header, not equal to header. And then we are doing a map here to read the lines from the data frame. Okay. Next, schema. And after schema, just check the column headers. And this is how the data looks like. Okay. Fine. So I'll just update the UI. Just a minute. This is part 3. Go to storage. Disk memory serialized to annex. Right. Now storage thing is now reflecting. So this one, what we are trying to do, let's see. Host 3.9 GB remaining. So 4 GB memory is required, available, and only 21.6 MB is occupied. Heap memory usage. Of heap memory usage 0. Disk usage. Now see how many RDDs are being generated. Yeah. Data distribution with one executor.
Pradeepta, there is a background noise from your side, a whistle kind of thing. Can
Yeah, I
you?
think yeah, there is some alarm going on so from my backend.
Okay.
Just give me 1 minute. I'll just do something on this. Is it better now?
Yeah, seems fine now.
Okay, perfect. Now here you can see cast partitions 8, number of partitions 8, one executors, data distribution on one executors. Okay, what does this mean? Let's understand this, right? 8 partitions. Now the data is being distributed across the partitions. What is the total memory size? 21.6 MB, right?
Yes.
Now here it is not equally distributed. See, 3.1, 3.1, 3.3, and 3.1. So this is 9 MB. So 1, 2, 3, 4. So 12 MB. This one is 3.
21 MB.
Right? So 21 MB. Now this is spread across 8 different RDDs. Okay. This number of partitions, as I told you before, right? So the concept of partitioning and parallelism. Now, obvious question you can think of is why we are doing Spark computation? Because we want to achieve massive parallel processing. Okay, so what is parallel processing? And let me explain the concept once again here. Okay, so when it comes to Spark, Spark supports cluster computing, right? What does that mean? And cluster computing means many computers, they are combined together as a cluster, and we want to avoid the read-write operation so that all the computations can happen within the cluster itself, so that you can achieve massive parallel processing, right? So the structure of, let's take this is your full data. This is your full data that you have, right? And these are your partitions. So let's take this is one partition. This is another partition, another partition, another partition, another partition. Which means you have how many partitions over here? 1, 2, 3, 4, 5, 6, 7, 8, 9 partitions. I'll remove the last one. So let's take last one is not there. So 8 partitions you have. Right. And how many executors? Right. So this is total data, and total data is having this many blocks as partitions. This is your full data, and these are your partitions or blocks, right? So you can call it, this is P1 up to P8. Clear now? Now here, how many executors you have? You can have 8 executors, right? Executor 1 up to executor 8, that also you can have, right? Or which means in this scenario, your partition 1 is staying in executor 1. Partition 2 goes to executor 2. Partition 3 goes to executor 3, and so on and so forth. Okay. So Spark in a cluster mode, how it acts is that it splits the data partitions across executors in order to achieve parallel processing. That is why these RDT collections, right? This is distributed across different nodes. These executors are nothing but different nodes. So a partition in Spark is basically, it's a logical division of data stored in a particular node of the cluster, right? The more partitions you have, the more parallelism you can achieve, right? This has positives and negatives both. So too many partitions is a problem, Too less partitions is also a problem. If too less partitions, you can not achieve the full potential of parallelism. Too many partitions, you can achieve parallelism, however, with some bottlenecks. I'll come to those bottlenecks later, right? Because see, these bottlenecks are not present in less partitions. These bottlenecks, there are certain things which will make the process of parallelism too complex to handle. You can achieve parallelism, no doubt about that. But these bottlenecks, they slow down the parallelism as well. What is that? Okay, that I'm trying to explain now. Okay, so any questions till now?
Now, when you divide into 8 segments, right? So we'll have executors for each of the segments by default.
No, see, executor is like predefined. So let's assume you have predefined those executors. 8 executors are there in your cluster.
Okay.
Okay, because your executor is not decided based on the partitions. Remove it. You make it executor as 4.
It's like a thread, right? You can assume.
You can just make it as 4. This is second executor. This is third one. And this is fourth one. Here you can say this is P1 and P6. This is P2 and P3. This is P4 and P7. And this is P8 and P4.
So this decision is done at the community edition by itself, right? Databricks itself will do this decision. How many?
Yeah, mostly it is automated. We don't have a play over here.
Okay. And it
We
selects thread, right? You can assume it as
see, while defining this initially, we don't have any option. It happens automatically. Now, do we have a provision to modify it? Yes, we can modify it. Okay, that concept I will explain.
so this can be RDD, right, sir?
Sorry, this can be,
RDD.
these are RDDs only.
Okay. Okay.
So either it is RDD or it is data frame. Data frame is by default RDD,
Okay. Okay.
right? So if you have huge amounts of data, and this is the total data block, let's take total data that you are uploading, right? And there are considerable number of partitions that you are saying. So here I can say that, hey, I have 4 executors, I have 8 partitions. Okay, so the data is basically key value oriented, right? So the keys, or you can say the comparable keys, if it is in the same partition, then the number of shuffling is minimized. Okay, let's assume the partition 1, it has customer ID. All the customer IDs there in this, right? And there is a customer name, which is over here. If you have this customer ID and this customer name, this is in partition 1, this is in partition 5. So P1 is from here, P5, this is P1, P6, P2, P3, P4, or this should be P5. So P1 and P5 both would be called in here, and you can pull the data. You don't have to shuffle the data, right? You remember the keyword count example I have given you before? Anyone remember that example? You have different sentences. Each sentence becomes first tokenized. Key one default mapping key would be assigned. Then shuffling operation will happen. In this case, are we doing shuffling? No. Your entire customer ID is stored in partition 1. Your entire name is stored in partition 5. You just call P5 and P1, you get your data. Rare shuffling happens. Now, customer ID is there, customer ID is here, customer ID is here, customer ID is here, right? Name is also present in multiple partitions, right? In this case, imagine the number of shuffling that you will be doing. Is it clear?
Shuffling as in?
Shuffling as in, okay. See, this one I explained you before, right?
In map reduce?
Yes, MapReduce. Remember this slide?
Yeah.
Mapping step, what we are doing? We are simply tokenizing and assigning a default value to it.
Yeah.
Right?
Yeah.
Now there is a shuffling stage here, which is not being shown over here. What does this shuffling do is, it takes one Peter, look for Peter in other partitions. Now imagine this is in partition 1, this is partition 2, this is partition 3, this is partition 4. The role of a shuffling is that it picks up one element and it searches for similar information in other partitions if it is there. right? Similarly, the word picked is also being searched across all partitions. So there would be each and every element would be searched in each and every partitions. Now think about the crisscross that is happening. This is searched here, here, here. This is searched here, here, here. So a lot of shuffling operation happens over here. That is why. So Peter is being picked up. One is there. And then it will also search for, okay, Peter is also here. Peter is also here, right? Now, things that are common or things that are repeated, this would be assigned default values. So the one level of reduce operation happens over here. Peter is 2 from these two partitions. Peter is 2 from these two partitions. Then again, a reduce operation happens. This text, this reduce operation requires, and this reduce operation requires a formula. So the formula is sum operator. So count. This is the count, and you sum it up. So Peter count is 2 and 2, and you combine it as 4. Clear?
Yeah.
But actually, in the shuffling stage, each and every element is being searched across all data partitions. Exactly similar way here. Similar information is being stored in different partitions. Now you are parallelly searching across all nodes for customer IDs, right? Now, once you get the customer IDs retrieved from all those nodes, wherever it is stored, what you will do, you will first see the unique customers from this, and combine it. From this, combine it. Then from these two and these two, then again combine it. That's how you'll get a global list of customer IDs, right? Which means the lot of shuffling is happening over here. Yes, no.
Yeah.
If I change this scenario slightly, now what I'll do, I'll remove those 4. Only I have 4 partitions. Only I have 4 partitions. So the number of shuffling would be less here in comparison to here, right?
Yeah.
Isn't it?
Correct.
So 2 less partitions, you can achieve parallelism to a certain extent by avoiding this read-write input heavy operations, which is called shuffling. Okay. Now, is it really parallel processing? No, it is not parallel processing. See, just imagine that your customer ID, you have a million customer IDs, right? And you are just taking from this and this, okay? And you want to achieve parallel processing. It has a limit to it. Why? You are just reducing the read-write operations here because you have less partitions. However, the normal processing time would be bigger here, right? Because you are not leveraging the parallel processing. Clear? So question here is, what is the right partition? How do we decide it? Too less is a problem. Too many is also a problem.
The size of the data.
Correct. Size of the data is also a function and kind of operation you are doing, right? So I'm just saying one example here. There can be different operations here. One is, let's take group by key, order by key, aggregate by key, right? So sum of sales by customer, average sales by customer, number of products by customer, right? Top 100 customers by value. Just imagine these kind of queries if you SQL queries you want to write on a million customers database. right? Million customer database, let's take it is 10 GB. The full data is 10 GB, right? And these are the queries that you want to run. So first, what you have to do, you have to do sum of values over all in million records, right? Each unique customer ID, how much value they are to you. Means one customer, he came yesterday, purchased 50 rupees, today 500 rupees, day before yesterday 1000 rupees. So you sum up all those values by customer ID, right? So you'll compute the sum of total value till date by each customer ID and print two columns. Then you do a sorting, sort it in descending order. Then you pick up a filter which is top 10, top 100, right? So three things you want to do. First, you want to do a aggregate by key. Then you have to do a order by key. Then you have to do a filter by key, right? Three things you have to execute. Now just imagine the processing time. Okay. This way it will take time because you are not really leveraging the potential of parallel processing. This way, too many partitions, there are too many calls, input output heavy calls, right? That could happen. Now, how can we avoid these input output calls by writing some kind of intelligent functions? So we can do more data partitions. We can write queries in order to reduce these bottlenecks, right? So that we can achieve parallel processing. Now that will come by experience only. You just have to experiment this. So at this moment, there is no right way. There is no right way to figure out how many partitions would be required. Clear? This is, you start small, increase the partitions. If you experience those bottlenecks, then pull back. Don't go ahead with that plan. Okay? So this is like an iterative baby step you have to take to figure out what is the right number of partitions. There is no science behind it. There is no formula behind it. Clear? Now, I told you that these are the queries. Operation wise, what functions you can see in your code, right? Sometimes you can say, I have done PySpark programming, but my processing time is still the same. It is not improving. What do I do? How do you optimize your PySpark code? First, you have to see what all functions somebody has used, right? The functions that you need to replace, or at least you need to be careful about, are co-group, group by key, right? These are some of the examples. Please be a little careful while using this. Okay. So if we increase the number of partitions and we minimize the number of read-write operations while doing data pre-processing, right, we can achieve massive parallelism there. Clear? Any questions? See, and when you read online also a couple of blogs, they say that, okay, you increase the number of partitions and you will achieve parallelism. But there is a limit to it. You cannot just increase to 100 partitions, 200 partitions to achieve parallelism. That is absolutely not possible. Sometimes you will never get parallel processing capability. Any doubts, any questions?
We are good, Pradeepta.
Okay. Now, second thing is that bottlenecks that I said, right? So one of the bottleneck is input and input output or shuffling. Okay. Bottlenecks in using more partitions. Number one is input output or shuffling heavy operations, which are actions, transformations, etc. That is one of the bottleneck. Second bottleneck is that executors. I would say number of executors. Third is executor memory allocation. Okay. So here I said 4. Now I had how many executors now? Here 4 executors, right? I just reduced the partitions. Now, which means virtually I have now executor 1 here and executor 4 here. This is the best combination, right? Less read write would happen over here. You know why? Usually those partitions, right? Usually those partitions, they do not span multiple machines. 4 executors means 4 machines, worker nodes you have. Maximum 1 or 2, but it will not span. Like you cannot just say that partition 1 is present in this machine, this machine, this machine, this machine. Not possible, right? Mostly the partitions stay in one executor. Okay, so if P1 is in executor 1, P2 in executor 3, P like this, so on and so forth, why would the shuffling operation happen over here? Right? So one of the most important way to increase parallelism is to increase the number of executors in the cluster. If you are using more partitions, increase the number of executors as well. Now, executor, if you are going to increase, it will add to your billing. Because the more executors you add, the more machines you are providing for horizontal scalability, right? Each machine has a cost attached to it, right? So how can we achieve this then? Now this way also it works. So here you can say if my data is there in like partition 1 is there in customer ID, partition 6 also contains customer ID. So P6 and P1, they both exist in one executor. It is fine. So if I'm looking at customer ID and P3 and P8, they are in 2 different executors, which is fine. Right? Now, what will happen if both the partitions stay in one executor? It is easy because here over network data shuffling is not happening. Because if there are 2 machines, if they want to exchange data, one data is here, one data is here, that would get communicated over network, right? So if we have significant network traffic in terms of sending data between executors, it will slow down the process. So we would like to minimize the input output operation or network traffic of sending and receiving data across different executors. So we have to increase the number of executors, and definitely if you have more data to operate or work on, billing would increase. That is fine, but the moment the work is completed, you just shut down the machines. Okay, so see, everything has a positive and negative here. There is no like you can say magic wand, or you, I mean, I would say there is a rule of thumb, you just follow it and it is done. No, it's not like that. So you have to be little cautious about using PySpark there. So billing will increase if you increase number of executors. If your number of executors are not more, a lot of read write operations would happen, and over network data exchange will happen between various executors, which will slow down the parallel processing. Because see, actually the Apache Spark reads data into the RDD, right, from the nodes and the nodes that are close to it. Customer ID, customer ID. So the closer thing is P1 and P3, so it will read, right? Communication between those executors, right? The less it is, the better it is. The more it is, it will slow down. So we don't want to see if you do. There is something called, if you remember, I told you last time also. There is in outlier. Outlier was there in this. Huh, it is there. Why it is approximate quantile? I told you this one before, right? Can anyone explain why it is approximate quantile, why it is not exact quantile? See, any kind of quantile computation, it requires the data to be arranged first in ascending or descending order. Based on that, see, quantile computation formula is what? I wrote it in the last session also. I was trying to explain, right? What is the quantile formula? Quantile means it divides the distribution into 100 equal parts, right? What is the distribution? How it works especially? Let's say you have some numbers, right? And you just say 24. Just take one example here. Fine. These numbers are arranged in a proper order. So basically quantile means 100 equal parts, right? So total number of parts here, which is the count, right? So count of values in this range divided by 100, right? Divided by 100, which is 0.12, which means this is first, this is second. So first element is your, this is 100th equal parts. Quartile means 4 equal parts. So divided by 4. 4 means third element. So 1, 2, 3. So 25 is becoming your Q1, quantile 1, which means this is your 25th percentile. Okay, 25th percentile. Next, multiplied by 3. So you simply do a multiplied by 3 by 4, which is ninth element. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this is your Q3, quantile 3. This is how the computation happens, right? This is your quartile 3, Q3, which is 75 percentile of your data. That's how it works, right? Now, in this case, what do you do? If this is already in ascending order, that's why it is easy. If the data is not in ascending order, And let's take these three are present in partition 1, executor 1. These two are present in partition 2. These three are present or 4 are present in another partition. This is in fifth partition. Different partitions, this contain different numbers, right? When you are pulling the numbers from different partitions and you are arranging it in ascending order, then on top of it, you are performing this computation to identify the quantiles. Sometimes the result may not be correct. Why? Because the data is coming over network and sometimes data loss could happen. That is why it is saying always approximate quantile. It is not exact quantile. Clear? Any questions? Now let's go back to this concept here. So the number of executors, definitely it will have an impact on parallel processing and executor memory allocation also. This is important because if your customer ID is a million and it is staying in one executor has enough memory, then probably the processing can happen in a very fast manner or faster way. One of the ways, see why the map reduce. The map reduce is basically reads and writes operations, performs read write operations. The if the data is already present in memory, you don't have to do read write operations, right? So ideal way is that if your data is in memory, you are avoiding input output operations. Significantly, you are reducing the processing time. That processing time can be used for computation. Okay. Any questions? Still, if you have some doubts, let me know.
Pradeepta, one question I have. So we are saying that by increasing the number of executors, we would be able to reduce the bottlenecks. Okay. So now, if we are increasing the executors, the network operations time will get increased as well, right? So if we see from the performance perspective, the time will get increased, isn't it?
No.
Because the
No, see, the reason for increasing number of executor is that we have to avoid the shuffling time.
yes.
Data shuffling would be reduced. See, the shuffling, if it takes more time, what is shuffling basically? Shuffling is basically your executors are exchanging data over network, which again they perform read-write operations. Any read-write input-out operations slows down the process.
Right.
Right?
Yep.
Is any other questions? Now I told you what are those operations, what are those functions that actually basically you can say consume time, or why? Because a lot of shuffling need to happen there. Okay. Now, okay, so we want to avoid the shuffling, right? The partition. Okay, let me go back to the previous graph. Here, this is a default partition, right? Executor allocation, while establishing or while creating a cluster, you are creating how many executors you want, right? If you want to increase the number of executors, you have to do a cluster creation once again, right? Yes, no? You have to churn up a new cluster or maybe increase it and relaunch the cluster. Yes, no?
Yeah.
Right? In those cases, that's a difficult process or cumbersome process, isn't it? Because here we are going ahead with the default partition. Partition controlling, increasing, reducing the partitions is within our hands. We can change it. However, executor increase, decrease, it is difficult process because you have to relaunch the whole cluster. So think about This allocation to a moderate level, maybe 6 or 7 clusters, you can set it up, or 8 clusters, 8 executors, you can set it up. However, the default partition is something you can check, and based on your need, you can increase or decrease those partitions. If you want faster processing, you are running these kind of queries for this unit faster processing, right? Quickly change this number of partitions, reduce the number of partitions to few, perform these queries. Once these queries are completed, then get back to this many number of partitions. That also you can do. So you can dynamically play with number of partitions. Clear? So let's go back here. What we're trying to do, we are performing some group by here. Let's just see how much time it is taking. Data is only 77 MB, right? We are just doing a group by count on gender. In this data set, the gender column has 1 and 2. What is the count of 1? What is the count of 2? Very simple, right? Just think how much time it is taking. Time will definitely come, so let's wait. Okay. Not even 1% it is processing till now. Not even 1%. Right? Here we said group by, right? And we don't know what is the number of partitions over here. Can we check what is the number of partitions to this data frame? Let's stop this or halt this. Stop execution. Job cancelled. Now let's go to fraud data frame dot. Let's see. Get method is not applicable on this. Show 5. This is fine. How did we read this? Okay, Spark data frame. Okay, so how do we get the number of partitions? So for a RDD, we can get it, right? So RDD, we can say, let's take RDD1, which is equal to Spark dot Spark context dot parallelize. Let's take, I'll take numbers like 0, 11 to 25. Some numbers I'll take. This is my RDD. RDD1 dot get number of partitions. 8 partitions. Why? Because local equal to 8, right? 8 partitions. Which means the data frame prod.df by default, it is getting distributed across 8 partitions. Okay. Now, if I want to change this to Let's take, I want to do 4 partitions. Get the number of partitions, 4 now. So I can change the number of partitions, right? Now, when you do the change from 8 partition to 4 partition, and you want to do, what's the way to print? Print is not there. Save as text file, and here let's take, we call it, we'll give a name. What's that? RDD1 print. Let's see the results. Okay, save as text file, where it should get stored. RDD1 print, right? We'll go to data, table, dbfs, RDD1 print. You can see 4 partitions here. Yes, no?
Yes.
These are Hadoop part files. Okay, partition 1, partition 2, partition 3, partition 4. And the job status is it's a success. Now I'll go back to once again 3. So I'll go here once again where we are doing these changes. So here, now I'll change it to default partition. RDD1 default partition, get number of partitions 8. Now print it once again.
Need to change the file name.
Yes, because if it is already existing, so here what you can do. Sorry. This is for 8 partitions. Go back to data, tables, dbfs, 8. Now you can see 8 partitions. Right? Okay. Now, next, what we can do, I'll go back to workspace once again.
What are those parameters for the parallelize 11 and 25?
What does that mean? The 11 to 25? It's a series of numbers.
I mean, they don't have any significance in
I'm sorry.
11 and 25, right? So
Series, it's just a number. It's just a number. So RDD1 dot show. Sorry. We can do tag or tag also we can do. What is that? collect it's just numbers. Okay. Now, there are two ways to do this parallelization. One is this one. While creating the context itself, you can define the number of partitions. That is one way. The other way is basically doing the partitions using a repartition method, right? Because here in this case, you have to reinitialize all the time. Now this one currently having 8 partitions. I want to change it to other partitions. So I'll do rdd1 dot repartition. And here, let's take, I'll call it 5 partitions. Done. Right? Now I'll check once more if rdd1 is having repartitions or not. Get number of partitions. It is not done. Right? Ideally, it should have happened, right? Now, can anyone tell me what's the problem over here? When you're doing repartition, you need to store it somewhere, right? So you have to do rdd2.
Yes, sir. So whenever RDDs are created, they cannot be modified. So that's
exactly. Now it's a new RDD. So it should be 5. Clear? Now, without reinitializing this Spark context at the import step itself, we should be able to repartition the data. Okay. And whenever we are doing repartition, we have to assign it to a new data set. Okay.
But this we are doing it with RDD. So, I mean, is it possible the same thing with the data frames?
Data frame, it is possible. We can do that as well. So in this case, fraud is a data frame over here. What happened? 63. Where is 63? Okay, this got broken. Okay. First, let's see. This is fine. So 5. This is fine. Now I have to do a repartition on this. So it is fraud df dot repartition. Now first we have to check how many partitions currently it is. Number of already it is default 8 partitions, right? That we know. So here we can do repartition. 4. Done. Now, when you do repartition, and already 4 we are mentioning over here. So we have to reassign it. We'll call it prodf underscore new. Okay. Now we can check this. We are reducing the number of partitions to half. So the query time would be little faster.
We need to change that to new then.
Oh, sorry. We have to change it to new. Should be a little faster. Let's see how much time it is taking.
Because shuffling will not be reduced, so it will be faster, right?
Hmm. Now shuffling would be reduced. That is why it should be a little faster. Taking also good amount of time. Why is it done or not? Let me check this. So what we did here, fraud dot data frame new dot uh, rdd dot okay, number of participants is not working. This is working. It slows down. Why it is slowing down? Okay, let's check. This is fine. Stages. Active task 1, which means it is still running. Okay. Let me stop the execution. This is fine. This is schema. This is also fine. And group by okay. So df.rdd.get number of partitions. This should be the method. It should ideally work here. Sorry, it is little slow, but I don't know why it is slow. Map partitions, map partitions, exchange. Still working, okay. Let's see how much time it will take. This is strange actually. Getting only number of partitions, it is taking this much time. Can you please check locally? Just upload any Spark data frame and just do get number of partitions. Are you able to get it? Why it is taking time? Okay, fine. So let it, oh, got it. 4. So we defined it, right? Repartition 4 and we get the result as 4. That means it's working, right? And instead we can run this as well. Let it run. Okay. So there are two different ways of getting those repartitions done. Guys, please focus on this. We saw the partitions, how it was being done earlier. Okay. So let's take, you have, think about this example that we have taken 11 to 25. Okay. 11, your RDD has values like 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 not included. Sorry, 25 we have taken, right? 25, okay. So 22, 23, 24. This is what we have taken. Now first you do division into how many part files? Part 1. Part 1 will have 1, 1, 1, 2, 1, 3. Part 2 will have 1, 4, 1, 5, 1, 6. Right? Part 3 will have 17, 18, 19. Part 4 will have 20, 21, 22. sorry, 22, then part 5 is basically 23 and 24. Okay, given how many partitions? 5 partitions. Partitions 5. Okay, now what you are using this, assume that this is your RDD. Okay, if you have questions, please let me know. Okay, this is very, very important. This is very basic and this is very, very important. Okay, so this one, yeah, this is getting done. 2.47 minutes it took, right? Now, if I change the default partition here on 8, right? So the earlier fraud.df, this has 8 partitions. df new, it has 4 partitions. Okay. Now, if I remove, or rather I should copy it and I do this. Let's run it in the backend. Okay. So if I do rdd dot repartition into how many? 4. From 4, what we'll do now? Tell me. Should we increase or decrease? Both ways you can tell me.
So currently it's 5, right? I mean, so we can increase it.
We can increase it. Okay, fine. Repartition, please remember this. Repartition, you can increase or decrease the number of partitions. So here you can say rdd dot repartition. Let's take 7. Now, if you do 7, so another 2 things, part 6, part 7 will be added, and some numbers would be splitted. Now, how that will happen? That will happen this way. You copy this, come back here. Now, this 13 will go from here. This will be 13, 14, 16 will go, 15, 16, this will go, 17, 18, 19, 20, 21, and then part 6 would be 22, 23, part 7 would be 24. Or this one, I will just remove it, 19. So this one starts from 19, 20, this is 21, this is 22, this is 23 and 24. Okay, so this is number of 7. Okay, now if I reduce this, what will happen? I reduce it to how many? Just tell me a number.
3.
3. Okay, if it is 3, these two numbers would go here. 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 These two, okay, 3 partitions, right? So I can take this also here. 18, 19, 20 here. and this is here, or maybe this will sit over here. This is gone, partition becomes 3. Okay, so 5 partitions, it looks like this. 7 partitions, it looks like this. 3 partitions, it looks like this, which means too many cells. Okay, that is fine here. So what is the takeaway here? Repartition goes for full shuffle, right? You understand now what is full shuffle? Because it is reassigning. See, reducing is easy, right? When you reduce the number of partitions, simply you just take part 2 and append it to part 1. Take part 3, append it to part 1. Then take part 4, append it to part 2. Like this. Which means you're actually not doing full shuffle here. Okay. But by default, when you are using repartition, the repartition always goes for full shuffle of your data, which is slow. It is relatively slow. What's the alternative then? Because here you don't have to always do a full shuffle. See, this was originally arranged. Now you do a repartition for 7. When you increase the number of partitions, it significantly, like it takes significant amount of time in reshuffling these things. Okay. So instead of doing that, there is another function called colesse. C-O-L-E-S-C-E. It is an alternative to repartition. Colesse, an efficient and alternate method for performing repartition. Okay. The catch here is that it only reduces the number of partitions. It cannot increase the number of partitions. Is it clear? Repartition, you can increase the number of partitions, you can reduce the number of partitions, both you can do. Increase and decrease of partitions you can do using repartition, which is basically a full shuffle of your data and which takes time. Okay. Which takes time. Now, in this case, in colesse, when you are using colesse function as an alternative, it's efficient, faster than repartition, but it only reduces the number of partitions. So default partition was 5. Now you want to do 3. Don't go for repartition because repartition again goes for full shuffle of the data. So you go with the colesse. If you want to increase the number of partitions from the default partition, then go with repartition. Now repartition will have both options, increasing and decreasing the number of partitions. Is this clear?
Yeah, Pradeep.
This is a very, very important thing I'm trying to say. Very, very important. And like even experienced people also, they at times get confused. They use repartition everywhere in the data. Ideally, for reducing the partitions, you should not use repartition. You should use only colesse. What colesse does is it repurposes the existing partitions instead of a full shuffle. It repurposes the existing partitions, avoiding a full shuffle of your data. That's why colesse is important and efficient in comparison to repartition. Hardly you will have any need to increase the number of partitions. Most of the times you will be getting a chance to reduce the number of partitions. Here, you go ahead with the default partition of 8, right? You want to achieve faster parallelism. But in some operations, you want to avoid the lot of input output calls or heavy lifting of data transfer over network between the executors. You want to avoid that. You want to reduce the number of partitions from 8 to 4. In those cases, don't use repartition. In those cases, only use the coalesce function. Clear? Fine. So that's all. And then you can do some description, like descriptive statistics here on this data frame. Then you can perform some aggregations, which is like finding out the aggregations are balance column, compute the skewness, and show me the result. Similarly, you can perform correlations between two columns, balance and number of transactions, right? And you can perform a correlations matrix for all numerical columns. Now here you are just taking length of number of numerical columns. So this will give you total number of numerical columns. This is a placeholder for storing a correlations matrix. Then you are writing a loop, right? Using this loop, you are trying to get one first numerical column and second numerical column, compute the correlation and append this correlation matrix. And gradually finish this correlation table for me for all numerical columns to look at the correlations at one go. This is one of the way to do. The other way is that using the built-in functions. This is one of the way. The other way is using built-in functions of correlations, and that correlations you can use the Spark data frame APIs. Okay, this is a normal way of writing, but the other way, this is not efficient. It is time taking, but the other way is correlation function directly API you can use from Spark APIs, Spark data frame APIs. Okay. After that, some data visualization using bokeh and all, which I will skip. The data visualization part I will skip completely because it's too easy. You can just run this script and you should be able to understand what it is doing. Okay, that's all. Any questions? Because the core concept understanding is very important, and we need to know what we are doing and why we are doing that. Okay. Still running descriptive statistics. It's fine. Fine. Any questions? Then we'll take a break, lunch break now.
Sure.
Yeah.
Sure, sir.
Yes.
Okay, fine.
Thank you.
So descriptive statistics is completed. This aggregation is running. It took also 2.4 minutes.
When should we be back?
1:30 by 2:30.
Right. Okay.
Thank you.
Yeah, okay, fine. Fine. So I'll share these notebooks also after the session. Thank you.
Thank you.